This is Dr. N. Amuthapriya, Associate Professor EEE from Rohini College of Engineering and Technology, Palkulam. We are discussing about the Transmission and Distribution course of Regulation 2021. Here we have the second lecture from the first unit. It comprises of the spiral and bundled conductors and the concept of GMD, mutual GMD, skin effect and proximity effects. First, let us see about the conductors. So as we know, conductor is not a single one, single layer. It consists of multiple layers, and when we are using a bundled conductor, obviously we get our losses to get very much reduced. And in this case, we can see that there are 7 conductors at the mid sector, and while considering the second layer, it consists of 30 conductors. All these conductors are of type of aluminium strands. The aluminium may be combined with the various alloys to form such a bundled conductor, and the resistance value is being given as R is equal to rho by A into square root of 1 plus pi by P the whole square, pi into L by P the whole square, ohm per meter. So the effect of resistance is directly proportional to the length of the conductor. Next, let us see about the self-GMD and mutual GMD. GMD is nothing but the geometric mean distance, right? So, while considering self-GMD, it is otherwise called GMR, geometrical mean radius, because self is nothing but its own radius. It is depending upon its own radius, and this GMR value is nothing but 0.7788 R. Normally, this inductance, which is comprising of the self-GMD values, being calculated as a inductance per conductor per meter, which is 2 into 10 raised to minus 7 into 1 by 4 plus natural logarithm of d by r. So while considering the r value to be 0.7788 r, we normally get this voltage. Next is, get this inductance. Next is the mutual GMD. Mutual GMD is nothing but the geometrical mean distance of one conductor from the other. If it is a double circuit, then obviously we will have 6 different conductors in a 3-phase circuit, and what is the mutual effect between the neighboring conductor and the one which is taken as a reference one. This is the value if it is DS1, the first conductor's self value is equal to dAA into AA dash dA dash A dash dA dash A the whole power 1 by 4, to the power square root of, not square root, 4th per root. And if it is self GMD of B, it's a combination of D and B dash. If it is a self GMD of C, then it is a combination of C and C dash. Next, while you are considering the equivalent value, you can take the cubic root of DS1, DS2, DS3 product. And next, while considering the mutual GMD, you have to consider A, B, B, C and then CA. Those combinations will give you DAB, DBC and DCA. And taking a cubic root of the 3 DAB, DBC, DCA product will give us the equivalent mutual GMD. This is how the mutual GMD and self GMD are calculated, from which you can directly calculate the inductance value per conductor per meter for a single phase line, and the inductance per phase per meter for single circuit 3-phase line and double circuit 3-phase line. This is a direction which will be easy for us to calculate. Next, let us see about the skin effect. Normally, this skin effect occurs in an AC transmission. The phenomenon which arises due to the unequal distribution of electric current over the entire cross-section of the conductor when it is being transmitted over a longer distance. It is called a skin effect in transmission. Actually, this will be playing a greater role in determining about electric stress in a conductor. So obviously, electric stress is nothing but which is going to directly affect the voltage value. So it's a potential, so it will be affecting the force value, isn't it? So this skin effect is a key parameter, and its effect has to be completely reduced. Not only completely, at least to a certain extent, it has to be reduced. But what we are using in the present era of power system engineering is predominantly an alternating electric current system. So where the electric current tends to flow with higher density through the surface of the conductor, leaving the core deprived of necessary number of electrons. Obviously, at the mid-center there will be no current flow. In fact, there even arises a condition when absolutely no electric current flows through the core. Right? So the concentration is more up to the surface region, and this will result in the effective electrical resistance of the conductor. This particular trend of an AC transmission system to take the surface path of flow of electric current is known as the skin effect, and this will be completely depriving the core. It will leave the core empty. That's it. Next is the proximity effect. Proximity effect is nothing but the impact of presence of one conductor over the neighboring conductors. The proximity means nearness in space or time. So as the name suggests, proximity effect in transmission line indicates the effect of one conductor upon other neighboring conductors. When the alternating current is flowing through a conductor, alternating magnetic flux is generated surrounding the conductor. This will be associated with the neighboring wires, and it will generate circulating currents. Normally we call it as eddy currents. This circulating current increases the resistance of the conductor and will push away the flowing current through the conductor. This may cause crowding effects. So this proximity effect has to be reduced, and this can be reduced by adapting a normal distance, I mean an acceptable distance between those two conductors. Thank you.